Okay, so let's talk about hardware coordination. Okay, every keystroke, every mouse click or touch on the screen, and every single signal to the printer and from the Blu-ray drive creates something called an action or an event. Okay, so it creates this event in the respective device to which the operating system responds. Okay, so here we have step one. You're watching a movie, okay? So the CPU is playing a movie. And then maybe at the same time you're writing a paper to, for class, all right? And so you're like, okay, I need to print. So you send it to print, and then the CPU receives something called an interrupt request from the printer. Okay, and we call it an interrupt because it just sort of interrupts what it's doing so that it can go do something else. Now it's still playing the movie. It doesn't stop playing the movie in order to send your document to the printer. Okay, it keeps doing it because, as we know, computers multitask now, just like we multitask. Okay, and so what it does though is, and now here we are at step 3, is it creates a little memo to itself. Okay, it has this stack in the RAM, and it creates this little memo to itself. So think of it sort of like a Post-it or something. And it's like, hey, here we are in the movie. Basically, keep playing the movie. Don't forget about that task, but now we're also going to put our main focus on printing this document. Okay? So, we move on to step 4 here, and the CPU now executes that printing. So, your paper is printed. Okay? Boom, we come down here to the stack. It grabs its little memo about the movie. Okay, it retrieves its memo from the stack. And then the 6th step is the CPU resumes playing the movie. Now, if we just read this through, like literally like what it says, it's going to sound as if your CPU is playing the movie, that it stops in order to print. Once it prints, it then resumes the movie. But as we know, as computer users, that's not how it works, okay? This is all happening like at blazing speeds that we cannot even fathom, or at least I can't, right? So it's all happening seamlessly, like in parallel, despite the fact that if you read through the steps, it reads as if, it's happening like one task at a time, okay? So it's kind of confusing, but it's important for you to remember that, okay? Like it's all happening at the same time. Yes, it's doing instruction by instruction by instruction by instruction, but just because it gets an instruction now or an interrupt request from the printer does not mean it's necessarily going to stop playing the movie, okay? It just sort of takes a little pause, and a pause that we don't even notice. Like it happens so fast that we don't notice. Okay, so sometimes I wish I could see you guys so I could see if I'm explaining this well enough or not. But if you have questions about it, read about this in your book, and ask me. Like we can talk about it too. Okay, and then you'll see the word spooler on here, and spooler is just a program that helps like coordinate all the print jobs that are currently being sent to the printer. So maybe you go to the library and you want to print, and like 5 other people are also trying to print at the same time to the same computer. So the spooler works by sort of putting the print requests in a queue. And so like whoever's request got there first, even if it's by like 0.0001 seconds, that's who's going to be first. Okay, so let's talk about memory and storage management. RAM stands for random access memory. Okay, remember we talked about that in our hardware chapter. And so it has a really limited capacity. maybe like 8 gigs. That's a decent amount of RAM to have. Okay, so when there isn't enough room in RAM, the OS borrows room from the hard drive. And when it does that, when it borrows that hard drive space, we call that virtual memory. Okay, you don't want to have that happen. Okay, if you're a little, a little note pops up on your desktop telling you that, that you're using virtual memory, you're going to be like, well, that's a problem. So you're going to want to increase the amount of RAM that you have in order to avoid using virtual memory. Okay. When more RAM is needed, the operating system swaps out from RAM the data or instructions that haven't been used recently and moves them to a temporary storage area on the hard drive. And so increasing the amount of RAM helps the computer to avoid having to send data and instructions to virtual memory. Okay. So every device attached to your computer comes with a special program called a device driver. And what that device driver does is that it facilitates communication between the device and the operating system. So kind of acts like a translator, basically. Okay. So you can see here we have your device manager list open. This is in Windows 10. Okay. Click on some of the hardware and it's going to tell you like what driver details you have here. Usually if there's any sort of updates, you can click on update driver and have that happen. Sometimes the updates happen automatically. All right. Plug and play is the software and hardware standard that was designed to facilitate the installation of new hardware in PCs by including inside the operating system the drivers that these devices need in order to run. So this is great because when you plug in a new device, you don't have to go and find the driver online. It's just automatically already built in with the operating system. You plug in your device, the OS senses what device it is, finds the driver, and there you go. You're all set. Plug and play, just ready to go. Every computer program, no matter what its type or who the manufacturer is, has to interact with the CPU by using computer code. Okay, so rather than having the same blocks of code for similar procedures in each program, what the operating system does is it includes the blocks of code which are called API, or the Application Programming Interface. Okay. Microsoft DirectX, for example, is a group of multimedia APIs that are built into the Windows operating system. And what they do is they improve graphics and sound. Okay, so we need to talk about the boot process. Okay. There are 4 steps in the boot process. Okay. So step 1 is called activating BIOS. And what this does is it manages the exchange of data between the operating system and the input and output devices. Okay. BIOS stands for Basic Input-Output System. Okay. And so the BIOS is also responsible for loading the operating system into RAM. So this is the very first step, like when you press the power button on your computer. Okay. Second step is performing the power on self-test, or POST. Okay. What this does is that it runs through all the essential peripheral devices and makes sure that they're attached and that they're operational. So for example, your monitor, okay, your keyboard, like your mouse, make sure all those things are working and that they're actually plugged into your computer. Okay, that's step 2 of the boot process. Step 3 is when the operating system is actually loaded into RAM, okay? And then the kernel, which is the essential component of the operating system, is then also loaded, okay? Step 4 is checking further configurations and customizations. And in this step, the registry it contains these different configurations that are used by the operating system and by the applications. So it runs through the registry, it's checking to make sure that operating system is working as it should, applications are running as they should as well. So those are the 4 steps of the boot process. Okay, Windows interface. So this is Windows 10. The desktop is your primary working area on the computer. Okay? And you have a taskbar. And what the taskbar does is it displays open and favorite applications for easy access. Okay, so here's your desktop here. Okay, here's your taskbar down here. So you can pin things to the taskbar, things that you use most often. So say you use Firefox, whatever, you just do a right click on it, and then it'll give you an option like pin to taskbar. And then you do that, and it's going to pin little icon down there. Sorry. And then the Start menu provides access to all applications and apps that are installed on your device. So this is your Start menu here. Okay, your most used up here, like recently used things are going to be up here. Here's where it gives you some suggestions. This is where your app list is, so this is alphabetized. You just sort of scroll through that. If you have any tiles happening, they're going to be here. Okay, if you don't want tiles, you can just again right click and like remove them, unpin them. Okay, and then your power button's here. Your settings button is right here, and then here is usually like your little login. So if you are using like a shared computer, that's where you would go and log out. Okay, pinning is the process of choosing which applications are tiles on the Start menu. All right, and virtual desktops just allow you to organize groups of windows into different displays. So like this. Okay, so that looks pretty fancy, right? So although the macOS and the Windows operating systems aren't compatible, they're extremely similar in terms of functionality. Okay, this here is Linux. Okay, this is what it looks like here. Your icons are here on the side. Okay, and different versions of Linux look different. Okay, they feature different user interfaces, but most of them, like Ubuntu, which is what this is here, are based on familiar Windows and Mac OS paradigms. So things like using icons to launch programs, and then having apps run in a Windows environment. And when we say window, I mean, this is like a window that opens up when you click on something. Okay, that's why Windows is called Windows. Isn't that neat? Organizing your files. So we'll run out of time while we're discussing this, but we'll get started anyway. This is a big function of your operating system, and it's to enable file management, okay, which basically just provides some sort of organizational structure to the computer's components and to the contents of your computer. Okay, Windows organizes your computer in a hierarchy. Okay, so it's this hierarchical directory structure, and it's composed of drives, libraries, folders, subfolders, and files. All right. If you go to the C drive, okay, which is right here, okay, anytime you see C, you're going to know that's your hard drive. Okay, basically it's like this huge filing cabinet in which all of your files are stored. Okay, the C drive is the top of the filing structure of your computer, and we refer to it as your root directory. Okay, so here's one of the Windows navigation panes. Okay, here's this navigation pane here on the side, lets you go through whatever you want to access, desktop, documents, etc. Your libraries are here, music, pictures, videos, documents. Okay, these are your folders, obviously little folders. These are file lists, so we clicked on Business 401, this is what's inside of there. And then this here is the file path.